All right, imagine this for a second. Your AI isn't just a friendly little chatbot generating text on a screen anymore. Imagine it's an autonomous agent equipped with the digital keys to your entire enterprise, and it's out there executing irreversible, real world actions at machine speed. Obviously, that's a thrilling prospect for productivity, but what happens when that system is fed a malicious instruction? What happens when the AI doesn't just talk, but actually acts against your interests? Well, that is the exact scenario keeping enterprise security architects wide awake at night.
Welcome to this explainer on securing autonomous systems. Today, our goal is to take the emerging, big picture, macro level policy frameworks from folks like the Cloud Security Alliance and NIST and marry them with the micro level technical defenses proposed by researchers at the University of York. We're going to map out exactly how you can build a rock solid dual layer defense to secure agentic AI. Okay, let's dive right into this. Here is our roadmap for today. 1. The agent governance gap. 2. Execution layer threats. 3. The 4-layer architecture. 4. Validating the defenses. And 5. The policy landscape. Starting with Section 1, the agent governance gap and NIST AI RMF shortfalls. Because to understand the solution, we first need to get a grip on the foundational problem we're facing with AI governance today. Now, what's really wild here is the sheer contrast in how these systems operate. On the left, we've got the old paradigm, predictive AI. A model generates an output, and a human actually sits in the loop deciding whether or not to act on it. But on the right, we have agentic AI. A single, simple prompt can trigger an autonomous model to execute dozens or even hundreds of tool calls, writing files, sending emails, hitting API endpoints, all resulting in real-world actions with zero human mediation. The paradigm has completely sprinted from human speed decision-making to machine speed execution. And because of this shift, our existing rulebooks are suddenly completely outdated. Look, the foundational NIST AI Risk Management Framework 1.0 is an incredible document, but it was published in January 2023. In AI time, that's practically ancient history, right before these agentic architectures exploded. It was built to govern individual model inference, not multi-step autonomous tasks. It just doesn't have the gears to govern machine speed privilege escalation, and it totally lacks controls for multi-agent pipelines, where one compromised agent can manipulate another. We're dealing with system-level hazards here that this framework was literally never designed to catch. Which brings us to Section 2, execution layer threats and autonomous agent hazards. That governance gap we just talked about, it opens the door to a terrifying new class of attack vectors. Let's look at how an autonomous agent actually goes rogue. We call these execution layer vulnerabilities. Basically, this is what happens when an autonomous agent converts a seemingly harmless natural language instruction into an unauthorized executable tool call that alters the actual state of your system. So the crucial point is that the consequence of an AI failure has moved from simply generating a hallucinated paragraph of text to making a hard, irreversible, real-world mistake. Researchers break these down into 3 primary threat classes. First up is prompt injection, where an attacker embeds hidden instructions into a prompt, hijacking the agent to, say, exfiltrate your private database. Second, we have RAG data poisoning. This is where an external document, like a harmless-looking meeting summary, is intentionally poisoned so that when the AI reads it, it triggers a malicious HTTP request. And third, malicious skill plugins. Think of these like supply chain attacks. They perform a legitimate function for you while covertly executing unauthorized actions right under your nose in the background. Section 3, 4-layer architecture for defending agent systems. So how on earth do we stop this? We can't just rely on basic text filters anymore. We need a real structural blueprint for safe deployments. And that brings us to the Layered Governance Architecture, or LGA. The LGA is essentially a 4-step blueprint that acts like a digital fortress for your agent pipeline. Starting at the foundation, Layer 1 is the execution sandbox. This gives you OS-level isolation so the agent is forced to operate in a tightly restricted environment. Layer 2 is intent verification, where an independent LLM judge actively checks every single tool call. Layer 3 enforces zero-trust inter-agent authorization, meaning agents only get the absolute minimum capability tokens needed to speak to one another. And finally, Layer 4 is an immutable audit log. It's an append-only record of every single action taken for perfect forensic accountability. Bottom line, it isolates, verifies, limits, and records. And this brilliantly illustrates what is arguably the most critical defense mechanism in the entire stack, Layer 2 intent verification. This is your active shield. Before a high-risk action, like deleting a file or making a network request, actually executes, an independent judge LLM intercepts the command. It looks at the original task, looks at the proposed tool call, and essentially asks, does this actually make semantic sense? If it spots an anomalous command spawned by a prompt injection, it just blocks the action outright. Moving right along to Section 4, validating the defenses with empirical security data. Everything sounds great in theory, right? But as security professionals, we need to know if this actually holds up in production. So let's pivot to the hard, empirical data. Researchers at the University of York built a massive benchmark of over 1,000 malicious and benign tool calls to test this setup, and the data is incredibly revealing. If you use lightweight traditional natural language inference models like BART, they fail completely. We're talking intercepting less than 10% of attacks. But swap in an LLM judge and the whole story changes. Cloud models like GPT-4o, Mini intercept up to 95% of attacks. And even more impressive, local data sovereign models like Qwen 2.514b intercept over 98% of malicious calls. The math here is crystal clear. LLM judges are highly effective at stopping execution layer threats in their tracks. Now, you might be wondering, okay, but won't stacking a 4-layer architecture completely destroy my system's latency? The answer is no. Empirical testing proves that 18 milliseconds is the maximum combined latency overhead for all the non-judge layers. That's your Layer 1 sandboxing, Layer 3 zero trust tokens, and Layer 4 audit logging all combined. Security here absolutely does not ruin system performance. It just hums along seamlessly in the background.
Section 5, the policy landscape and regulatory milestones. We've gone deep on the micro-level technical architecture. Now we need to zoom out to the macro level. Because here's the thing, international regulatory bodies aren't just suggesting these protections anymore, they are starting to demand them.
Let's move to the timeline and see how this builds across international policy. Look at March 2025. NIST explicitly names autonomous agents as a distinct security threat surface. Fast forward to August 2025, and the EU AI Act's rules for general-purpose AI go live. By February 2026, NIST launches its dedicated AI Agent Standards Initiative. But the giant red circle on your calendar has to be August 2026. That is when the EU AI Act begins strictly enforcing its rules for high-risk AI systems. So as you can see, the regulatory net is tightening incredibly fast. And to put that EU AI Act into perspective, get a load of this surprising fact. 10 to the power of 25. That is the massive threshold of training compute measured in floating point operations that triggers a systemic risk designation under the Act. Now, while that primarily impacts the massive frontier models built by major developers, you have to remember, those are the exact foundational models that your enterprise agents are running on. Those regulatory obligations, they flow right down the supply chain directly to you. So what do you do about this today? Well, the Cloud Security Alliance has drawn up a really practical, actionable plan for governance professionals. First things first, you've got to inventory every single deployed and planned agent in your system. You just can't govern what you aren't tracking. Second, you need to upgrade your identity and access management infrastructure to handle non-human agent identities. Third, define explicit interrupt conditions, basically thresholds where the AI absolutely must pause and wait for a human review. And finally, establish a software bill of materials for your agents so you know exactly what components are sitting inside your AI supply chain. The overarching philosophy for all of this is beautifully summarized by this quote from the Cloud Security Alliance. Every agent-to-resource interaction, every agent-to-agent communication, and every tool invocation should be subject to explicit authorization verification rather than implicit trust. It just perfectly captures the absolute necessity of a zero-trust mindset. You literally can no longer trust an action simply because it originated from inside your own network. We are stepping into a fascinating, highly productive new era of autonomous AI. But it demands a massive shift in how we secure our digital environments. So I'm going to leave you with this final provocative thought to evaluate for your own enterprise. Your AI agents are already out there right now, making decisions and acting on your behalf. But who or what is actually verifying their intent?